Hello, everyone. And on Thursday, I won't be able to meet students in the face-to-face session in classroom ITC 24 because I'm going to attend a robotics training class on campus. So we will cancel the meeting in the classroom, but I do ask students all finish the InClass number 8 forecasting in this week by Thursday. So you can use the online Panato video and follow the step by step. So please open your the InClass practice sheet number 8. So if you look at the number 8, I have 3 questions. Basically, it's one more practice about the forecasting methods. We use time series of weighted average and moving average, and also use exponential method. So different calculations. The last one is the third problem is the model of regression model we practiced in today's class. Here's one more practice to help you to retain the information. So hope you all open this file. Here, this is the first one. Okay, the following table gives the number of points of type A blood used in a hospital in the past 6 weeks. So these are the given data. And the first question, it is forecast the demand for week of October 12 using 3-week moving average. So here it is October 12. So let's highlight. This is the one we are going to answer. And uses a moving average. This is a moving average of 3 weeks moving average. So, okay, they didn't ask you others. You know, if you want to just calculate is 3 week, October 12. Demand. Because it's 3 weeks, so we can do 3 weeks moving average is sum of divided by 3. So all right, and also you can do this way. 3-week moving average. So equals to, from the 4th week, you have average of the first 3. So this number is the exact number over here. Decimal points. And the second problem is use a 3-week weighted moving average. So 0.1, 0.3, 0.6 as the weight. Okay, here, this one we want to use is weighted moving average. So equals to 0.6 times and plus 0.3 times the second week, 0.1 times this one, and divide by 0.6 plus 0.3 and 0.1. So B, you say demand of week October 12, and in moving in weighted method, weighted average equals to this number. So if you want to use the decimal point, just a slightly difference. Third one, forecast the week of October 12, use exponential smoothing. So exponential forecast. This 360, and also we need to give the alpha equals to 2, 0.2. So here equals to plus in 0.2 times and real actual demand. Let's subtract the prediction. 360. Then we so just fill in all of the formulas. We find out 374. These three numbers are the results we want. See demand of week October 12 in exponential method equals to 374.26. All right. And this provide you kind of like a calculation result, just to check your result whether it's correct or not. And for the second practice question, the actual demand for patients at Omaha Emergency Medical Center for the first 6 weeks of a year. So these are the data, given data. So we want you to find out, the clinic administrator wants you to predict the number of patients for week 7, but use weights for 0.33 for the most recent period, 0.25 for previous 2 periods, and 0.167 for one before that. And the second practice question is change the weight. So let's say the weight is, and weight is 0.333 and 0.25 and 0.167. So how about I do this and also do this, and so in this one is weight forecast with the weight of 20, 20, it's 20, 15, and 10. So I want to merge and center them together. So just a little bit to organize the table. Just make this organization better. Okay, it will not hurt you calculation anything. And for the first one, you need to use the for that. So week 7 will be in this row. So I will highlight week 7. These are our goal. So for this one, and we need to use 0.333 and times 48 plus 0.25 times 70 plus 0.25 times 62 plus 0.167 and times 65, and then divided by all the weight, 0.25 times 2 plus 0.167. So it is 60. About the decimal point. Okay. Now, using the weight forecast, you found week 7 is 56.76, about 57 patients. And changing the weight, so 20 times 48 plus 15 times 70 plus 15 times 62 plus 10 times 65 divided by 20 plus 15 times 2. 15 times 2 plus 10. Okay, here. Now we get a similar result, 56. Slightly change. And if you look at over here, and 20 divided by 20, the weight divided by 60 is how much? Oh, let's see. This weight equals to 0.33. If I'm using 15, the weight divided by and 60, now it is 0.25, and it equals to 10 divided by 60. This is 0.667. So essentially, if you are using the weight of this group and the weight of this group, they are same. So why you see the slight difference is because of the decimal roundup. So, and if you see my calculation 20 over 60, which is 0.333. And the next one is 15 divided by 60, which is 0.25. So this example shows you can use decimals as your weight, or you can use integers as your weight. And if all the the weights are proportion, and then it doesn't matter you use which one. So for the third practice, this one, it is a long one. And here, let's read the question in the beginning to see what are the requirements. Okay. So Jordan has been hired as a management analyst at a digital cell phone, INC. His manager and handed him table shown here and asked him to forecast the demand for the next 6 months. And each case contains one for 4 phones. So A is prepare the report using the least square analysis. Basically, you are asked to generate a linear line. So the linear line, you need to figure out what is B value and what is A value. And then Y equals to A plus BX. Your A, it is the intercept. B, it is the slope. And B is add a seasonal variation into the model and report the changes in the analysis. And the last one is a forecast using moving average, naive, and a weighted moving average method. So we are given the weights 0.2, 0.3, and 0.5. And I want you to observe the difference in different estimation method. So this one, and I suppose only, let you to remove this and let you to remove the average. And now you want to fill out these blanks and find out what is A, what is B, and then figure out what is the linear regression line. So you are given the 3 years data. So first one, the column we want to do is x squared. Let's do all of the square. So here, the next column is x times y. Times y. In this formula, in the in-class practice and or in today's lecture, we show the formula. These are the formulas we need to use. We need to calculate xy and x bar, y bar, and x squared we did, and x average. So these are the two formulas we need to A and B. Let's see if we can put this over here to remind us. All right. So now we need to calculate the sum of x squared. So sum of x squared from here, the first into the last. And this one, it is the sum of xy. So this one, it is sum x squared here. And this yellow filled lines is sum xy. And this is sum x, sum y. We do not really use sum x and sum y, but we need to use their average. So average, it is sum divided by 36 because it's 3 years data. And here is 3 years data. So sum, it is average y, 36. Now, we are ready to use the formula to get A and get B. So x bar, which is 18.5, and y bar, this is in 537.9. For x squared, we don't really need this this average, so we can leave the 2 as blank over here. For B calculation, we need to apply the formula. So sigma x and y, that's this one. Subtract n equals to 36 times x bar and y bar. So x bar and y bar. So this is the numerator divided by the denominator. And sigma square, x squared. So this one, subtract n, and it is 36 times x bar. So this is the x bar. So this one equals to, I want to make sure all my typed number, it is correct. So E sigma x xy, sigma, this one, and subtract n, 36 times b and c divided by sum x squared, subtract n equals to 36 times b 45. So I want to see. Three 7 8 6 6, yeah. Okay, the practice over here equals to sigma xy, subtract 36 times n, and it is x, here it is y, divided by sigma x squared, and subtract n, 36 times b. Okay, I think I need to check over here where is the mistake. So so missing a square value over here. Now your A equals to y bar. So y bar is subtract B. B is your calculation times and x bar. So Now we get our y value equals to A, it is 440, and 0.8492 plus 5.24, and times x. So this is the prediction equation. Equals to y bar equals to C537 minus 440. 0.8492. So this is the first one. Report the prepare the report using least square analysis. Now we have the least square analysis model. Add the seasonal variation to your model. So now we need to do this part. All right. And for seasonal variation, we want to use the first step is calculate the average of each month in the past 3 years. So for the past year, each month, we calculated their average. Now, what is the total of this grand, kind of like this is the total of the average? So then use this demand and spread it into every month divided by 12. So now you hit the enter key and do not scroll down yet. So use F4. So in my computer, I don't know, I need to increase a $sign in front of this and a $sign in front of here. So, and then I drag over here. Now we can calculate the seasonal index equals to average monthly demand of average demand of using the historical data divided by the average monthly demand. Now we can get all of the seasonal information. So with this, we can find out the insert, and this is the demand forecast. Seasonal, if you want to predict for the next few months over here, you can use the prediction to if you know next year 2010 the data. I think in this example they didn't give you the 2010, but we did figure out what is the seasonal index if we can forecast the yearly demand, and then for every month we can find out what is the monthly demand. So this one I'll leave this because the case study they didn't give us kind of like a specific number what will be the demand in 2010. So now just leave this as a blank, but our next one, it is to use moving average model, naive model to find out the demand. So for moving average, look at what is the weight or what is the information we need to use. Moving average, naive, and use three kind of like months average of the three. So let's see here. Moving average equals to average of here. Then we can find out the following month. For naive model, basically we didn't really have a practice from the in-class work, because naive model is the simplest model. Just assume your prediction of next month will be the exactly same number of the previous month. For example, naive of this model, and if you want to predict in January, you want to use the last December. So this one will be December. And the next one should be January. So okay. Where is this one? No, here. M8. This should be M7. Oh, 9. So naive model just use the previous one to be the prediction. For moving, where did I put? Okay, so this should not be my naive model. So this is naive. Naive should be this one equals to here. The moving average use 22, 0.3, 0.5. Okay, 0.5 times and plus 0.3 times plus 0.2 times this one divided by 0.5 plus 0.3 plus 0.2, which is 1. So did I use the right column? Oh, so UB M column. This is M column. So here it is M column. All right. Now, we finish all of the 3 in-class practice. Just one more round of forecasting, practicing, and solving problem, and before you take the exam. So again, use the time given, and the rest of the time given on Thursday, and you please also read your textbook and prepare for the exam during the weekend. Next week we will have exam.